We're about to start our executive series number 6 here with Dassault Systemes, focusing on virtual twins. We're here today with Jerry Jackson, who is the Vice President, Global Value Solutions for the Architecture, Engineering, Construction area. Dassault is a giant company, a global company that has traditionally been very focused on aerospace and automotive, and has launched a series of products for the AEC space. And Jerry is one of the people championing that growth for Dassault. And I'm a big fan of CATIA. I used that earlier in my career, and I know that CATIA is used throughout aerospace and automotive, and does all sorts of fantastic things to simulate products against all sorts of different conditions to help engineers engineer their buildings. So I'm very excited to learn about what Dassault has for digital twins and what that focus is going to look like. So with that, I'm going to turn it over to Jerry, who's had an extensive career working for HDR, working for Autodesk, and working for Dassault. And he's a technical expert with Dassault Systemes on virtual twins. So Jerry, I'll turn it over to you, and thank you very much for making the time for us today.
Sure, Tom. Thank you. And I hope my voice is coming through clear.
Yeah, you sound good.
Fantastic. Well, thank you, everybody, for joining. I hope everybody finds himself safe and well. As Tom said, my name is Jerry Jackson for Dassault Systemes. I manage the global, what Dassault calls the construction, cities, and territory business. What we probably are more familiar with, and what the term we use, is AEC outside of Dassault. And I do that on a global basis for the online portion of our tech stack, if you will, of our platform. So that's who I am, and I welcome you all here. And the goal today is really to take a look at who is Dassault Systemes. When I was first asked to do this, I thought we should probably introduce ourselves, if you will, because I think that if people are familiar with Dassault, maybe like Tom was earlier, a lot has changed. And then I thought we would kind of set that table, which will allow us to kind of move into this idea of how Dassault is thinking about virtual twins, what we call virtual twins. And how that fits into the context of the AEC, or what Dassault calls construction, cities, and territories. So let's get started with the getting to know the Dassault side. So let's talk about what Dassault believes, and essentially has always believed, and it's still with us today, stronger than ever, as we all are here remote. And that is this idea that the virtual world extends and improves the real world. And in this case, I thought I would use an image from one of our larger customers, Meyer Werft in Germany, where they are creating virtual twins of what I really think is the closest and most fascinating to the construction industry, and that is shipbuilding, and the way they go about digitizing ships because of their density and their scale, and the modular methods they use for I call it construction, but I guess we can think of it as a hybrid of manufacturing and construction. So that's our belief at Dassault Systemes, a strong long-term belief in that the virtual world extends and improves the real world. The other is our values. So something at Dassault that sticks with us is this idea of challenging the status quo. What you're not going to find about Dassault is that we sit still, or that we only look for today's problems to solve, but the more challenging problems. My grandfather was a Danish carpenter, and he used to always say to me, Jerry, the second that you find yourself comfortable, get uncomfortable, right? Or choose to do the hard thing and not always the easy thing. So sometimes that's very true about Dassault, this idea of challenging the status quo. Another way of looking at it is from a Frenchman at the turn of the last century, the late 1800s, a Frenchman taught Wilbur and Orville Wright that this idea that no bird soars in a calm, which fits along with this, trying to find a storm, if you will, and challenge that status quo. So these are things, as you engage with Dassault, begin to think about what we're doing and why we do it. It's that idea of what we believe in, which is that virtual side I just mentioned, and then this idea of challenging the status quo. So a little bit of an overall look at Dassault. We are a scientific company. We are an R&D company. That's core into what we do, and you'll see why, because that's really essentially why and how we started. Today we have about 19,000 employees, representing 130 nationalities at 181 different sites, with 64 R&D labs globally. And probably, we were chatting before this went live, and probably the people impacted by everybody needing to work at home most are the R&D labs, because they're used to so much co-locating in an office and collaborating, and now they find themselves kind of remote here. We have, in terms of partners, we have just over 12,000 partners: software, technology, sales, education partners, research partners. Worldwide, in terms of users, we have just north of 25 million users, representing 11 different industries and 140 countries, and 250, 250,000 customers. And we're a long-term driven company. We have kind of a majority of shareholding control, which allows us to hold on to that long-term vision. Our revenues, I think, as of last year, were just north of $4 billion euro, which is probably about $4.3 billion dollars in US dollars. So our founding, Dassault Systemes, I like to say, not actually Dassault Systems, but Dassault Aviation, which founded Dassault, spun off Dassault Systemes later. But Dassault Aviation, which a lot of that majority stockholding exists, that Dassault Aviation started 104 years ago by Marcel Dassault, just before World War I. That company kind of changed right after the end of World War I. It started with the Hélice-Claire propeller. That was Marcel Dassault's kind of first invention, first innovation. So he was a tier one supplier, if you will, to the burgeoning aerospace industry back then. After World War I, the major aircraft manufacturers back then kind of told him, hey, you better go look to do something else, because the governments are out of money after World War I. And as we know now, are more cognizant now, there was also countries throughout the world were also facing a pandemic at the end of that war, the 1918 pandemic. And as a result, you have Marcel was kind of told, hey, you better invest someplace else, because propeller makers are not going to be getting the big contracts. So I tell the story because he actually invested in construction and real estate, and built a few facilities, just outside the downtown parts of Paris in their early years. And then World War II, when countries of Europe started to arm themselves, people that Marcel knew said, hey, now's, with World War II approaching, people said, well, now's the time to re-enter. So Marcel took some of his real estate assets, used those assets to go capture a factory, because now he no longer wanted to just make propellers, but the entire aircraft. And so it kind of shows a long history in the built environment space, even from the earliest founding days. And I've included here a couple of quotes, which these quotes capture still the culture of Dassault. That really hasn't changed. And you can see it when it comes to what we believe in, and kind of our always willingness to challenge the status quo. Well, let's kind of bring that history and a dual history, if you will, to Dassault Systemes. So Dassault Systemes started its early days of being, I won't say founded, but the core technology in the mid to late 70s was starting to come about. The coding, if you will, was beginning around CATIA. Back in those days, it was actually called CATI. And so there was a small group, I want to say, if my memory serves me, about 6 to 8 people that were doing the coding inside of Dassault Aviation. A few years later, Dassault, what became Dassault Systemes, the product CATIA, was spun out of Dassault Aviation, and it became known as Dassault Systemes as we know it today. And those early days are represented in, at the real start in 1981 with that spinning off. And right away, Dassault was always a 3D company. And so we were always proposing 3D design. It's really what Dassault Aviation was trying to do with the early product around airplane wings, aerospace wings to start with, to go directly from 3D, directly to fabrication. So that's just been at the core. It's why kind of we exist to some extent at the beginning. So that was 1981 and 3D. Well, we know if we think about the construction space and those that are developing the design and engineering in the construction space for what will ultimately be executed in the field, in 1981, we know that to be manual drafting. And so at the time Dassault was inventing 3D, let's call it the AEC market for our terminology, was manual drafting. So nowhere the idea of digital 3D just wasn't there in 1981. So there was quite a divide between Dassault and what the AEC industry was doing. Now, if we fast forward to kind of another landmark time that many of you may have heard about, if you weren't too young in the mid-90s, and you can remember, there was quite the stir, I'll tell you. Back in those days, in the mid-90s, I was teaching high school. I was teaching 3D and digital manufacturing at a high school not too far from where I live today. And I remember picking up the paper. I don't remember exactly what publication it was, but it was announced that this company called Dassault Systemes had done a complete digital mock-up of a Boeing 777. And even if you were very young in those days, or you were part of some industry in those days, we can appreciate that, because at that time, in 1991, there was no real World Wide Web. There was, I think, Windows. Microsoft had Windows 3.0 at that time. So you can really gain an appreciation of what was going on. But it was remarkable, this idea that in 3D, that you can completely create a digital mock-up of a product, right? Such as a 777, was remarkable to everybody. Well, the AEC industry should be very proud, because right on the heels of Boeing, think about this, right on the heels of Boeing, who commanded, by the way, and during that time, a significant part of the worldwide aerospace industry. Airbus was not what Airbus is today. And we have other startups around as well. But back in those days, Boeing, the supply chains listened, and they made up a big portion of the aerospace industry. If we move to the top of 1989 and 1991, again, like I said, AEC can be very proud, because Frank Gehry had just kind of received the contracts for the Disney Concert Hall, and to some extent, with kind of not getting into the details, the Disney Concert Hall and Bilbao at the same time. And so Frank hired someone by the name of Rick Smith. I don't know if that comes through in the slides or not. It's kind of in small print. But in 1991, he hired a gentleman from IBM to join Frank Gehry Partners And at that time, all Frank had were drafting tables. That was it. Of course, he was always a big physical model builder. Those existed, but it was, in terms of drafting, it was all manual. So he brings in Rick, and Rick brings in this technology called CATIA at the time, and it was CATIA v3, the version 3 of CATIA that Rick brought in to Frank's office. So think about that. An architect, Frank Gehry, on the heels of what Boeing did. It's remarkable. I've got, contact me sometime later and I'll give you a couple good book references that I don't think I've included in the handouts to this presentation. But it's a remarkable history, and AEC should feel very proud of that. You can see some of those screen image above. That's Bilbao being digitized in CATIA at the time. Now, perhaps we could smile because that screenshot is actually a physical camera picture. There was no print screen back in those days, right? So that's a picture, like a Kodak picture, not a digital picture, a Kodak picture of a screen, computer screen showing CATIA. And then if we fast forward to 1999, give or take, for Dassault was getting pressure that people said, okay, look, Dassault, we've digitally mocked up an entire aircraft, but, and that's a remarkable accomplishment. Everybody's agreeing so, but now that it's digital, that mock-up, how do you manage the life cycle of the digital product, its assembly, and all the constituent parts? And then how do you manage the digital life cycle of that? So Dassault, started investigating and proposing this idea of product lifecycle management in 1999, which meant that Dassault kind of had to start to take a little departure from file-based CAD, which would have been that version 3 CATIA that Boeing started with, to what our last kind of file-based 3D, which was CATIA v5. Dassault had to kind of take a departure and said, well, if we're going to go to the product lifecycle management, this has got to be data-based and not file-based. And so as a result, as Dassault moved into databases, the AEC industry, those that were involved around Frank Gehry projects and other complex projects, remained file-based. So you're going to see a little bit of departure between where Dassault needed to go for aerospace and automotive, and with the realities of AEC. So you're going to see kind of a division here for the first time. AEC with Frank Gehry was right with Boeing in 1989, 1991 with DMU. Not much difference. But as we get into product lifecycle management, AEC couldn't quite follow along. And as you even can see today, the notion of product lifecycle management, some may call it project lifecycle management in the AEC industry, but that's even a new concept. And so there was kind of parting ways. And so Frank and team, what later became Gehry Technologies, kind of remained in this CATIA v5 world where Dassault had to move on. But even though Dassault moved on into product lifecycle management, if we look directly above that, and we see in 2003, I grabbed an example of Arup here, creating the Beijing National Stadium that I think, again, many of us would recognize as kind of groundbreaking. And if we think back to 2003, as that's being developed for the 2008 Olympics, we saw images, if we remember back, of this national stadium. And all of us basically said, how are they doing that? Like, how would you even fabricate that? How do you manage that, that level of detail? Well, they were doing that with something called knowledge-based engineering. So while AEC could not jump on board of PLM, product lifecycle management, they did invest in knowledge-based engineering with CATIA. And that's going to repeat as we go further along here and dig in a bit more. And then finally, we had to where we are today. In 2012, Dassault launched the 3D Experience platform. In 2014, we made that platform available on the public cloud. So now it made this entire product lifecycle management, this pure database-driven methodology, available to the smallest of firms. And so now AEC and Dassault were back in sync. And that's represented by a project that was started in 2014, I believe, in the fall of 2014, completed in Canada, in Vancouver, completed in early summer of 2017, 100% on the 3D Experience platform and on the public cloud, and done by the architectural firm is listed up above, but the digital process engineers, if you will, was CAD makers. That's been well written about. It's almost as famous with the high-rise mass timber as perhaps Bilbao was in the earlier days of Dassault's history, but still groundbreaking nonetheless. I actually kind of favor it because sometimes people associate Dassault Systems with and it's very proud, with a kind of a complex Frank Gehry curvature type of building, and not like a rectilinear building like you might see that CAD makers executed on behalf of the University of British Columbia. And so that kind of resets the stage of what's possible and the use. So going forward, referencing that, as we go forward in 2020, we're not leaving anything behind. We're just leveraging it all, and we're extending ourselves into humans. How do you then begin to create a virtual twin of human beings? And that's where we're heading to next. So again, maybe going back to nearly my first slide, you can kind of see where that challenging the status quo comes from. You can see where that belief in the virtual improves the real. That hasn't left at us. It's not leaving us today. So, I was trying to find a quote that captured maybe how you can, maybe one way, not the only way, maybe one way you can think about Dassault. And I think it captures it fair. Albert Einstein was quoted as saying, everything should be made as simple as possible, but not simpler. And that really captures Dassault. It really is project lifecycle management. It's really this knowledge-based engineering, because the physical world is no doubt not a simple world, but we need to have people who produce it and consume it. We need to make it as simple as possible, but no simpler than it is. We have to capture all its complexity, right? So that this quote is a good way to think about Dassault. Let me see if I did not go too far here. No, I did. I'm not going to spend a lot of time on this slide. This is part of the handout. I very lightly touched upon it, but this will give you a frame of reference. What Dassault delivers is the 3D Experience platform. That platform, think of our own R&D at Dassault Systems as developers on that platform. So each of our brands could be SolidWorks, could be CATIA, could be Innovia, could be NetVibes, could be 3D Excite, could be Delmia. Think of them as developers for the platform. So everything they make uses that same data model, that same geometric kernel, and which makes this kind of flow of data, what we talked about before, so remarkable. Okay, so let's look at the context for digital twins. Let's take a look at the context for this. So let's look at the left. Let me kind of orient you to this chart, to this grid here, to this graph. So if we look at the bar on the left going vertical, what I'm trying to do here is take and say, okay, we have physical products and we have digital products. Those products could be the built environment. Those products can be software. They're physical and they're digital. Now, going horizontal to the right, we have, how do we distribute those products? We can do physical distribution, or we can do online distribution. And so that's what this continuum looks like in those both X and Y direction to orient yourself. Without trying to draw on the screen to slow things down here, what I'd like you to focus on is the top horizontal. I kind of, I don't know, I just kind of named different CAD methodologies and file systems versus database systems. I just tried to give them some kind of name we can all kind of look at and think about. Well, if you think about CAD systems, and I'm leaving out a whole bunch of stuff, product lifecycle management, project management, I'm just oversimplifying here. But if we look at CAD systems, computer-aided design in general, they're all digital products. That's why they're high up on this on the y-axis here. However, they haven't always been delivered or distributed in an online fashion. Okay, I think we can agree there, right? I can remember back in the day receiving physical boxes of a CAD software, right? And then gradually over time, they became digital and they also became online. Some, if we go to the extreme, are actually streaming CAD. So there's no code locally installed, right? Now let's take ourselves out of AEC. Let's take ourselves out of AEC software, and let's look at where we saw that happen in other industries. So we look at the music industry, like in North America, there was something called Tower Records back in the day. And of course, for video, there was this idea of Blockbuster, which kind of was somewhat global. And we know what happened. We know that story. Music kind of went to Napster, where it became more of it was partially physical, but it transitioned to digital. Then music moved into iTunes, which was still physical, kind of where it was stored, but you can do the online commerce and trading, if you will, digitally. And then gradually those turned into pure streaming products, right? So this is to set the context of what we mean by virtual and why Dassault treats it so important to what we believe in. So I hope that made sense, okay? So let's take a look at the next slide. If we now look at what you and I and we all are involved in delivering, buildings, bridges, products that will find their way into the built environment, the things that we're producing, in the beginning, these things were produced, if you look at the left side, the kind of dotted line outline, these products were very much physical. They, since the 90s, let's say, they've always started some kind of life, not right away, but started some kind of life as a physical product, maybe on sketching paper and other forms. But they also became digital, sometimes in just 2D CAD, for example, in the early days. But they did find themselves digital, but for sure, 100%, whether digital or hybrid or physical, they were physically distributed. That's why you find them on the left side. Today, I think you guys will all agree, the products that ultimately find themselves as physical products, a building, a window that goes in a building, whatever, a bridge, whatever, they are almost instantly digital. So they would go high up on the y-axis in terms of the production of them, right? And they've extended themselves in that virtuality far into the cycle where people are dealing with online commerce of that virtual product. But what happens now is when we go to start to deliver them physical on site, and just before that, all of our virtual becomes physical and they drop back down. So it drops down on the y-axis. So the question is, how do you extend the virtual side of this so that the development of the built environment is a digital product on the x-axis, but is the online trading around that digital product is online, right? How do you extend those things? Because if you do extend those things, it gets really fascinating. All kinds of new business models around delivery begin to be formed. And I think a lot of you listening will start to understand, like, you experience it day to day, that clash, because there's a clash of that digital and that physical, and it's not a pretty clash by any means. Well, Dassault, where do we fit in this continuum, this X and Y continuum? We're very much in the upper right-hand corner. Starting last year, maybe it's been a little more than a year now, we're even delivering our first streaming CAD as well, let alone the other apps that are all developed on the 3D Experience platform. So of course, you would know it from the very first slide I showed, we are very concerned and fascinated by challenging that status quo and with the virtual, right? So it would not surprise you we're in the upper right-hand corner. So the value of digital twins, let's walk through that a little bit. So the value, oh boy, this is like a good one. I hope I can explain this one. I decided to use a graph I think many of us have seen. And I think I'm going to rush through this a little bit faster than I want to, but I wanted to talk about the value of virtual twins in terms of a graph. Well, so do me a favor before I go to the next slide. Think about that continuum of digital physical and of physical distribution and online distribution. Keep that in the back of your mind as I go to the next slide. Here too, we have an X and Y continuum. And, you know, this sometimes Patrick McLeamy with HOK is credited with this graph. It actually was done out of a civil engineer from Stanford originally kind of proposed it. And Patrick at HOK kind of brought it into kind of more quote unquote the modern era. But this is the original graph. And this is to say, the x-axis is looking at product delivery, the different phases. And the y-axis is kind of looking at cost and the ability to affect change. And the notion here is, hey, look, as you continue along product development, it gets more expensive to introduce change. And also as you go further along, your ability to impact cost decreases. While at the same time, introducing change causes an increase in cost. We know that definitely when something transitions from the virtual to the physical world, right? We all know what it's like to be on a construction site and a change happens, right? That just gets, you know, sometimes it can feel astronomical in cost, let alone, you know, hurting the motivation of the crews that actually have to be on site to do that change. So we're very familiar with this curve. Let's look at it, how it starts to change. What Patrick McLeamy started to do was to say, okay, if that's the case, well, we need this idea of around integrated project delivery. Hey, you know, which isn't a bad notion, right? It's this idea of, hey, if we start talking early and start sharing information earlier, then, hey, look, we get ahead of these curves. And you know, we can impact cost, and we can also introduce change without cost getting out of control. That was the idea. Not bad. But, you know, the problem with it, honestly, is it's accepting the current constraints as unchangeable. It's moving effort. It's moving the natural flow of design and fabrication and manufacturing and offsite fabrication. It's moving that flow, trying to make it so early on that it's kind of not real. It can't be real. That's just not the way decisions and that are made and discoveries are made. But it's suggesting that you have to move that bell curve forward, because again, it's kind of accepting technological constraints to some degree, and business models. Let's be fair, right? I mean, the business models of the construct. You know, it's not just that. But what I would like to do, and from Dassault's values, this idea of challenging the status quo and keeping things virtual, right, is to not accept those curves. And I guess if I don't steal, you know, borrow too much from the conditions we're all in today around the pandemic, it's kind of like flattening the curve, if you will. You hear that term a lot in context of the pandemic, but in a sense, that's what I'm saying. Don't mess with the bell curve. Let that bell curve be wherever. Effort will go up and down. It's impossible to predict. Every project condition is the same. But what if we challenge the curve? And so if we challenge the curve, which requires a change of, which also requires that earlier graph of saying, okay, how do we keep things a digital product, but also online distribution? And then
Jerry, sorry to interrupt. I just wanted to give you a heads up on the time. We do have a hard stop at probably no later than 4:27 because we got to start the next panel.
Okay.
So I just wanted to make sure you're conscious of the time.
Yeah, thank you. So the idea here is, how do we change the curve? So the value of virtual twins is flattening the curve, simply put, right? And the details of the virtual twin are around this idea, if I were to steal from neurons and synapses and kind of relate it back to Dassault, if you can't model every single detail to the nth degree, no matter what the scale of the project, and then you can't attach knowledge to each of those smallest details so that those parts, those features, the entire product assembly can understand and adjust, then it's really impossible to live in this world. And the way Dassault's been able to do it is through two core technologies of ours, and you can Google these if you'd like, but one of them is our geometric kernel, which is called the convergence geometric kernel, sometimes the CGM 3D kernel, if you were to Google it, and our knowledge language, our digital knowledge language, which we call EKL, Enterprise Knowledge Language. You combine those two things together, and you're able to take what is human tacit knowledge about execution in the field, design and engineering, and you're able to take tacit knowledge that human beings have, and you're able to make it digitally explicit. And that makes those two graphs we studied totally possible. So with that, let me end it by offering a definition, which comes from the book Life 3.0. And that is this idea, and this definition, that virtual twins, it's a process that can retain the built environment's complexity and replicate the information specifying how it was delivered. And that gets back to all of the things that we discussed, but for sure, this idea of capturing, reusing, digitizing knowledge tied to the highest level of detail. With that, I have delivered some handouts. In those handouts, you'll find some references that you can look for yourself to see, and with a couple of examples. And with that, I thank you and wish you the best of the rest of your day.